Okay, so guys, this is what we were doing last time, right? We were talking about ideal gases, and he said that all the different processes the ideal gas can go through. We first talked about the work done, then we talked about the cyclic process, we talked about the free expansion, we talked about constant volume pressure processes, constant pressure processes, and isothermal processes. I want you to keep these things in mind a lot because they are going to be very important moving forward, as well as when you guys start talking about your engines and stuff. These are all going to be very essential. So for people who are in engineering, guys, these formulas are going to be vital, essential when you guys get to wherever you're going. Now, a little bit of chemistry. You have seen these equations in chemistry, and you may or may not have realized where they come from. So like, for example, PV gamma equals a constant. Well, if you have not done it yet, you will do it. But here's where you're going to learn where it came from. Okay, we are going to begin. So I'm going to do this last one today. So what is an adiabatic process? So an ideal gas undergoing an adiabatic process. So what is an adiabatic process? Q in equals Q out equals 0. No heat flows in or out of the system when you are doing work. So from the first law of thermodynamics, which said delta U equals Q plus W, what may I write for an adiabatic process? And what was W? Right? So W is negative P dV. Okay, so how is this achieved? Well, this is achieved when we consider two situations. Number one, our system is thermally insulated from the surrounding. Or number two, the process happens in such a way that the system does not have time to exchange heat. What do? We limit our time in our process under consideration where heat exchange doesn't happen. Good? Okay, and I also want to do a caveat here, but the system still is quasi-static. Which means, okay, so if I look at this equation, let's call this equation 1, because it's the first law of thermodynamics. What can you tell me about this equation? When work is done, what is happening to the system? So for example, let's say it's a compressional work. Good. And what will happen to the right-hand side of this equation? delta U will go up. Yes. When delta U goes up, what happens? James? Temperature goes up. So we can say for all adiabatic processes, are accompanied by changes in temperature. Temperature may go up or temperature may go down, depending on what kind of work you do. Okay, so now for equation 1, may I write delta U equals W? For small changes, may I write NCV dt equals minus dW? No, sorry, plus dW. My bad. So this is going to be dW when you look confused. Okay, what's the question?
The MCY. CV.
There it is.
Okay.
Why did I put an N in it? Because I don't know the number of moles. Right? Okay. Good question. Are we good so far? Or may I also write this as NCV dt equals negative PdV? Okay, I want you to box this and remember it. I also want you to box this and remember that. Call this equation 2, equation 3.